I'm here to talk about security, but particularly the aspect of security that doesn't deal well with people, or vice versa, the aspects of security that people don't deal well with. And that's what I'm talking about when everybody does everything wrong. Before we get started, this is research. These are not commitments, these are not product roadmaps or anything else. Also, at the end, I want to hear your feedback. It can go into the app, or you can follow us back to our booth. That's the HPE Labs area. Pedro here is easy to spot with his white coat. I'll be putting my white coat back on when I get over there, and you can give me feedback directly. You can also send me email or anything else. So I want to hear that. But the central thesis today is that one of the biggest ways that people lose out on security is just by misconfiguring the systems, just by setting them up wrong. I know I've done that. I know there's famous headlines of people doing that. Thank God I didn't wind up in the headline. But the reasons for this are pretty simple. Tell me, anybody here who has had a system that was just kind of too complicated to deal with? Anybody ever set up IPsec to be compatible with somebody else? Anybody here who fully understands all of the security settings in S3? I mean, me. There's all kinds of complex systems that are just too hard to use. There's also too many ways of proving your identity. OAuth, Active Directory, Kerberos, all of these systems. There's different access control models. There's users who don't pay attention to what you've got. And there's changes to controls that will have surprising effects somewhere else. Anybody heard any of these? Seen those? Yeah, him. I can tell the people who actually do this by the people who raised their hand, because anybody who didn't raise their hand hasn't actually seriously done this. So I grouped these into several groups. And the top one I call too many, just the perils of multiplicity. The second one, too complex, the perils of things you just can't figure out what they were intending. And the third one is too limited expressivity, too limited in terms of what you could handle and how you can set up the controls you need. Let's address too many first. If we look at it, anybody who's in a big corporate environment has their current identity system, for instance. They have their legacy system, which is where most of the apps still are. And you have the aspirational system you're going to shortly. You always have those three. And you've got 3 or 4 acquisitions. Each of them have their legacy, current, and future. So it's quite typical to have a dozen different ways of proving identity. Each one of those is entangled with all of the access controls. So as you try to move applications forward, you have to go back and re-replicate all of that. That's a nightmare. So I've drawn several on the left. On the right, we also then have lots of ways of storing data. Each one of those tells you who can get to it and who shouldn't get to it in different ways. So you've got just a cacophony of all of these systems. And every one of them wants to be the center of the world. Every one of the authorization systems wants to be how you control things. Every one of the storage systems wants to be, it's also the same kind of control. So I want to refactor this and limit the mission of the systems on the left and on the right, pull in some stuff in the middle. So all we have on the left is proof of identity, not all of the excessive stuff, and abstract out the identity. So a single identity could have multiple ways of proving that an application has access to it. This makes migration much easier, for instance. Then I also want to factor out and make the storage systems have a much simpler mission. Instead of a full Boolean logic of who can do what and what attributes might enable you, I want to limit it to just enforcement. And so then in the middle, we have policy identity, abstracted identity, and controls. And I want to make those controls and all of that simpler. Now, we've implemented part of this in our research. The parts that have the thick lines around them are fully implemented, except the wavy thick lines are fully implemented, but for the last version, we have to bring them forward. So we already have this running across a realistic cacophony, a realistic diversity of systems, both for storage and identity. And we have it running on some seriously realistic scenarios for corporate separation, for small project security, and things like that. And in particular, one of the most recent systems that we've worked on is integrating this with Deos. So you saw probably the supercomputer display over there with El Capitan. Another one of the supercomputers that we built recently for Argonne National Labs, Aurora, is by far the fastest for I/O. And that's because it uses this system called Deos. It's almost a factor of 10 faster than the number 2, which also uses Deos, which is a factor of 8 faster than the number 3, which does not. So it is fast. And the integration with Deos turns out to be simple. And this is the pattern that we see in this kind of integration. This is kind of a timeline of how an application and a user would interact with the system. Up at the top, we have the login process where the user is getting a credential from the access manager. The second step is where their own program is getting a delegation token from the access manager for Deos. All of the rest of the steps are identical. Only the steps in green are changed relative to a normal program. And the 2 green steps are things the user doesn't actually see. And so the porting to this system, getting the universal controls, getting access over all of the Deos instances, having universal identities rather than just this Unix system, that Unix system, having to match identities based on user ID number, all goes away. And the user doesn't have to do anything. This is what I mean by make it simpler and yet much more general. So the next one would be too complex. And what we do there is try to take the idea of setting up rules and simplify it to almost the bare bones. So probably the simplest way to express an enablement for some operation, like read or write, is an access control list. That's insufficient. Because if he's the head of IT, he's the manager of my department, and I'm managing something, the access control lists on the data in my system can't be affected by him because he doesn't know what my requirements are, but he won't trust me to manage that correctly, so we'll wind up sending all the requests probably to him, then to him, he'll make the change, and we go round the circle very slowly. So instead, what we're going to have is a system where all of the data, all of the users and the roles and the workloads are arranged hierarchically. And then we'll have multiple ACLs at different levels that are inherited. And that lets us have a very simple logic, nearly as simple as ACLs, but it lets us do some very nuanced things. And importantly, one of the things that we can do in this idea, so we've got data up at the top, we've got 2 companies, Acme and Yoyodyne. Well, we can put permissions on the Acme company that says to view any Acme data or to see any Acme attributes or any Acme users or the Acme workloads, you have to have the role Acme user. Who has that role? Well, first of all, those permissions are inherited down through those trees, and then we put that role one place on the Acme root user directory, and so it's inherited by all the Acme users. So this guy, as the IT manager, manages that one attribute, And by that, he guarantees the global compliance that only Acme users can see Acme data. Now, there will be more details to be supplied on an application-specific basis, but he is now guaranteed that high-level policy compliance. He can also explain it to another manager. He can say, this attribute is required, this attribute exists in one place, everybody inherits it, and nobody outside the company has it. And I, or he, is the only one who can change that. That's the level of complexity we want in a security situation, where you can explain it, essentially in an audit, in 30 seconds. Anything more than that exceeds short-term memory, and it's too complicated to have serious confidence in. Now, those two companies are both going to do that, Acme and Yoyodyne. So Yoyodyne, who's the arch competitor of Acme, that's a reference to Buckaroo Banzai, the wonderful movie. But Yoyodyne will see this. They will only see Yoyodyne. Acme, on the other hand, will only see this. They will see only Acme. Acme does not see Yoyodyne. Yoyodyne does not see Acme. There could be co-tenants in an adversarial sense and still very safe. It doesn't matter what permissions are set below that, because the visibility constraint will prevent all the other accesses that you don't want. So this idea of inheritance of simple controls allows us to have separation of concerns. Lets the central IT person to manage their concerns, lets the department manager manage their concerns, and me to set up the DevOps setting in the way that I need to have it set up. It also makes the logic of it, in a mathematical sense, very simple. We'll get to that later. So now we get down to the question of too limited. And here's an example where we have a trusted data path. We have trusted data processed by trusted workloads, all inside of a security contour that nobody can see in, and the trusted systems cannot exfiltrate from. But we also want to develop software. So the green steps, the circles are programs, the squares are data. That's the trusted pipeline. The pink steps below the dashed line are developmental workloads. Now we can set up access controls so that development workloads cannot write to production data, and production systems cannot read from developmental data. And we can do that simply. So we've added dev and production directories for data, and dev and production directories for workloads. And we put attributes. Of course, we have still the Acme user attribute, but now we have Acme dev and Acme production on those two directories. That means to add those attributes to a program, we just have to put the program in that directory. We don't have to actually manipulate the attribute. So I can freeze the security architecture of a project and have the DevOps engineers do the correct thing without ever messing up that architecture. And then the permissions are just what you'd expect. Developmental data can be read by developmental programs. Production data can be read by dev or production and written to by production. This is simple. But this level of control is difficult to manage in conventional systems, because we may have some supercomputers doing AI, we may have some normal computers doing data acquisition into a system like S3. Getting this consistent across those systems alone is difficult because of the expressivity in these conflicting systems. The key points is that everything happens by inheritance, not by developer action, not by how the developers have to configure things in the moment. promotion to production status is easy. You just put something from one directory into the other. And the necessary administrative privileges can all be controlled because there are permissions on the attributes, on the users, as well as the data. And everything above this, you remember the IT level controls, those are unaffected. Those are inherited and unchanged. So we have the separation of that control. Now, another property which most users will not care about, but those organizations who have very serious security constraints will care about, is the fact that all of this is logic. This is the core semantics written in data log. Here it is written in Lean, where we can write these very simple, informal mathematical systems, and then we can write mathematical proofs of compliance with policy. These mathematical proofs can be used as policy unit tests or semantic unit tests, so that every time we change any of the metadata, we run the unit tests again. If we are in a compliance situation, but the change would take us out of compliance, we can pause that and examine what we're doing. Either there's a bug in the policy or there's a bug in the step we're about to do. And that can help us control and maintain very interesting and complex constraints. For instance, set it up so that there are always 3 live administrators on this project, that you never remove the permissions so that you would reduce the number to less than 3. That's a very, very difficult thing to express in any sort of access control system, but it's relatively easy to express as a simple mathematical proof about the state, so that any change you make has to preserve that proof. Does it resonate with anybody? You want to try it? This is non-public research at this time, but I'm working to open source this. There's a lot of approvals and so on. The key parameter for succeeding in open sourcing this is feedback from customers. If somebody wants this and says that, then we are almost certain to be able to open source it. If nobody says that, well, there have been 5 or so customers already, but without that sort of acclaim and pull, it won't happen. So what I would like to offer here is that we make this more than just an internal research project, but make it much more of a collaborative research project, where we can work with you guys to make sure this is really what we want. Now, there are systems that have some of this, notably the data fabric. Data fabric, the HPE data fabric was part of an acquisition where I was CTO, and it had some of these ideas of inheritance, but it was limited to one kind of storage. We've extended that. You also see things like Open Policy Agent, where you can put policies in the middle, but they're very complex still, so you can't reason about them. So we've taken some of those ideas, but I think we've taken it in a place where we're aggressively maintaining the usability of the system, aggressively keeping it simple enough that people understand it. And the result, I think, is quite different, especially when it comes to metacircular inference, where the governance governs the governance, so that we can not only say the system is good as it stands, but nobody can change it into a non-compliant state. So thank you very much, and that's how we can make things easier, simpler, and help users do things right.